Hello, this is Mrs. Pullen for Algebra 2. In this video, I'm going to go over problem number 37 from the Algebra 2 January 2023 exam. Objects cool at different rates based on the following formula. And this formula, thankfully, you do not need to memorize. The initial temperature is represented by T sub 0. Room temperature is T sub R. R is the rate of cooling of the object, and T is the time in minutes that the object cools to a temperature of T. Marx makes t-shirts using a hot press to transfer designs to the shirt. He removes the shirt from a press that heats the shirt to 400 degrees Fahrenheit. The rate of cooling of the shirt is 0.00735 and room temperature is 75 degrees Fahrenheit. Use this information to write an equation for the temperature of the shirt, T, after T minutes. So let's substitute in the known information. Well, room temperature is 75 degrees Fahrenheit. The rate of cooling is 0.0735. The initial temperature, so the minute that Mark removes the shirt from the hot press, it starts cooling. So its initial temperature of the shirt is 400 degrees Fahrenheit. So we want to write this as an equation. So we just substitute into the formula. So T is equal to 400 minus 75 e to the negative, don't forget that negative here, otherwise you would be incorrect, 0.0735 T, and then plus the room temperature is 75. And you don't need to simplify it in order to get full credit for that section. Parts. The next part says, use the equation to find the temperature of the shirt to the nearest degree after 5 minutes. Well, that represents lowercase t. So what they want you to do is substitute into the formula. So 400 minus 75 e to the negative 0.0735 times 5 plus 75. And instead of breaking this into pieces, I would type it in just like you saw. So I go into my calculator and I go to a calculator page, and we're going to type in directly as we saw it. So it's going to be 400 minus 75, close the parentheses, E, don't forget the negative sign, 0.0735 times 5, hit the tab so you're on, not in the exponent anymore, and then it's plus 75. And you get 300.0505. So to the nearest degree is 300 degrees Fahrenheit. Okay, next. At the same time, Mark's friend Janine removes a hoodie from a press that heats the hoodie up to 450 degrees. After 8 minutes, the hoodie is at 270 degrees Fahrenheit. The room temperature is the same at 75 degrees of Fahrenheit, but instead of solving for capital T, you're going to use a slightly different equation to find the rate. So these values are now changing. So your initial temperature is now 450 degrees Fahrenheit. Room temperature is 75. The rate of cooling is undefined. And they gave you two other clues. They said after 8 minutes, it now cools to a temperature of, we're going to do capital T, 270 degrees. So let's substitute in. So 270 is equal to 450 minus 75, close the parentheses, e to the negative k, because that's what we're solving for, t. T is now, lowercase t is 8 minutes, plus 75. Actually, they call it R, not K. Sometimes they call it K. Okay, so what would you do? I first simplify, so 270 is equal, 450 minus 75 is 375 E, and I would write this as negative 8R plus 75. You want to isolate the power of E, so you're going to subtract 75 from both sides of the equation, and you get 195 is equal to 375 e to the negative 8r. We're still not, the power of e is still not isolated. You now want to divide both sides by 375. So I'm going to write that here. 195 over 375 is equal to e negative 8r. Now, you want to solve for the exponent, so you want to log both sides, but when you have a base e, it's easier to use ln, the natural log. I'll show you why in a second. So we're going to take the natural log of both sides. We're going to get ln of 195 over 375, and I'm going to apply the power rule, and the negative 8r is going to go in front. So it's negative 8r ln of e. Well, it turns out that ln of e is just 1. You can memorize it or you can type it in the calculator and you would see that. So that makes the arithmetic easier because now I can really ignore the 1 and just divide both sides by negative 8. So in your calculator, you're going to type in ln of 195 over 375, that's the argument, divided by negative 8. So let's enter that in the calculator. So control LN, that's the EX button to find that. Control division, so we get that fancy frac. 195 over 370. Whoa, I have to do that again. I don't know how that happens. Control ln, control division. 195 divided by 37. Oh, here we go. I did it again. Let's try this one more time. Oh no. I don't know how that happened. 195. Oh, I'm having problems. It doesn't want to listen to me. 375. Okay. I'm going to have to do this in pieces. Enter. Divided by negative 8. And then you round. Sorry about that. So it rounds to 0.0817. So we have only one more part, 0.0817. So that's the rate of cooling. 10 thousandths is 4 decimal places. Remember, tens place, hundreds place, thousand place, 10,000 place. Okay, last part. The t-shirt and hoodie are removed at the same time. Determine when the temperature will be the same to the nearest minute. So although you can try this, solving this algebraically, this problem is much easier to do by setting one side, the two equations equal to each other using the graphing calculator. So the t-shirt, remember that the equation is 400 minus minus 75 e to the negative 0.0735 lowercase t plus 75. And the hoodie, that second temperature, is 475 minus 75 e to the, we just calculated it, negative, don't forget the negative, 0.0817t plus 75. And then we're going to enter those into the graphing calculator. So I'm going to go home, go into my graphing calculator, and type in the equation. So just as I saw it. So 400 minus 75, close the parentheses, e to the negative 0.0735, and you have to do an x. The calculator will not accept the t, plus 75, and hit enter. Don't panic that you don't see anything. We'll talk about that afterwards. Now let's do the second equation. 450 minus 75, close the parentheses, e to the negative 0.0817. And then don't forget the x instead of the lowercase t. Get out of that function, plus 75, and hit enter. Now, the reason why you don't see anything is that notice that there's like that high value in front, the 400. Whoop, I don't know what that's doing here. Those high values. So you're going to have to change that window. So to change that window, menu, window zoom, and window settings. I'm not quite sure what the X-min and the X-max will be, but you can't have negative time. And I would probably start off by making to the right 30. We may have to adjust that. I would leave 1 minute negative 6.66, although really your temperature is not going to drop below 75. But I'm going to make this 450 because that's the highest it could go in, as far as the temperature. And I'm going to hit OK. And now you can see the equations. Now I'm just going to move my labels because they're in my way. And of course, I'm having trouble. And so now I want to find the point of intersection. So I'm going to hit menu, analyze graph, intersection. You want to be to the left, and it could be that far to the left. And now I shift to the right, and I see that point of intersection is 17.453, 165.121. So for a test, you'll have more room on the actual test. They just, in this book, they just did shrink a sheet of paper. You should sketch out that function. They only, when you're solving for this, they only want, so again, as I said before, you're going to sketch it out to receive credit. The point of intersection is 17.453, comma 165.121. But again, they only want the when. When is the x, the time, the lowercase t. So that would be 17 minutes. And that would be the answer. But again, you do need to show the sketch. I hope that this video was helpful, and that you are healthy. And I'm going to see you tomorrow.